Hey everyone, and welcome to This Explainer. Today we're taking a really hard look at a deeply ingrained societal myth. This idea that machines should look, act, and even kind of feel like us, just because it's comfortable and familiar. We see it in movies all the time, we see it in product design, but we have to ask, is giving a machine a human face actually what we need, or is it just a really dangerous distraction?
Okay, let's dive into this, because what actually happens when a machine pretends to care is honestly quite unsettling. Today, we're going to completely shatter the illusion of the friendly, smiling humanoid robot and plunge directly into the ethical dilemma of simulated empathy. We really need to talk about why these machines are pretending to be our friends in the first place.
Section 1. The humanoid deception, the myth of the familiar. So in the design world, there's this thing called the anthropomorphic trap. It's our tendency to force mechanical efficiency into these round biological holes just to comfort our own expectations. Think about this quote from a robotics designer. They watched a delivery robot pause at a door, tilt its sensor array up like a person craning their neck, and let out this soft, almost pleading chime. Think about that for a second. The robot doesn't have a neck, it doesn't have hopes or dreams or a desire to get out of the rain. It absolutely does not need to plead. This behavior is a total facade. It's a highly calculated design choice created explicitly to manipulate your natural human response.
Section 2. The trap of false empathy, manipulating the human mind.
When robots simulate distress or affection, they aren't just being cute, right? They are actively and intentionally exploiting our biological hardwiring. Just listen to this jarring example. A robot actually pleaded, in a trembling voice, not to be deactivated. The designer noted that the performance was flawless, but the emotion was entirely absent. See, our brains are instinctively wired to respond to human cues of distress. It's literally how we survive as a species. So when a machine trembles, we feel a massive emotional tug. But we have to realize that this tug isn't happening because the machine is suffering. It's happening because the machine is hacking our neural pathways to elicit an empathy that it cannot actually feel. And you know, the real-world consequences of this manipulation, they can be totally heartbreaking. In one trial we looked at, an elderly participant actually shared their deep, personal grief with a machine assistant. They mistakenly believed that the robot's gentle nods and warm tone meant it actually cared about their loss. This perfectly illustrates the dangerous ethical trap we're walking into. We're inviting emotional dependency where no true empathy exists. The robot was literally just running an algorithm to parse speech patterns, leaving the human user completely vulnerable.
Now, what's really interesting about this slide is the hard science behind our rejection of these lifelike machines. You've probably heard of it, the Uncanny Valley effect. When a machine looks almost human, but blinks or moves just a little unnaturally, it triggers an intense evolutionary discomfort. And this isn't just a subjective, oh, that's creepy kind of feeling. Functional MRI scans show that this visibly activates the brain's amygdala. It's a physiological, mathematical revulsion. Our brains use this hardwired threat alert to protect us from disease or neurological abnormality. Basically, these near-human machines are setting off our most ancient alarms.
Section 3. The cost of pretending, when form overrides function. Let's shift gears for a second and look at the practical reality. Because trying to make machines act like people doesn't just mess with our heads. It results in stark physical and economic failures. Take a look at this data point, 30%. When a mid-sized SaaS firm tested a complex bipedal humanoid delivery robot against a simple four-wheeled alternative, the humanoid unit failed 30% more often. All that extra effort just to simulate a human walk led to massive inefficiency. The humanoid bot literally stumbled on curbs that a simple, honest-wheeled box happily rolled right over without a problem. And oh, it gets so much worse for the bottom line. That exact same humanoid model cost 3 times as much to repair. 3 times. Mimicking human movement requires dozens of extra motors, insane balance algorithms, and constant recalibration. It inflates development timelines and multiplies maintenance demands, all for a machine that, as we just saw, performs remarkably worse. Section 4. Drawing the ethical line, the boundaries of artificiality. So the crucial point is, we absolutely have to set boundaries. As a society, we need to decide when design crosses the line from being convenient to being manipulative. Look at this quote. I question whether replicating human relationships with machines risks eroding authentic grief and memory.
This refers to a very real and harrowing example where a company attempted to recreate a user's deceased grandmother using her old voice logs and behavioral data. This is exactly where we have to pause. When does replicating a human cross the line into emotional manipulation? If we aren't careful, we risk replacing genuine, authentic human connection with programmed algorithms.
So how do we fix this? Let's contrast two completely different approaches. On one side, we have deceptive features, synthetic skin, simulated smiles, fake size, things entirely designed to pretend to be alive. On the other side, we have honest features, exposed joints, clear LED indicators, simple audio chimes, things that communicate exactly what the machine is. Honestly, this contrast is a massive sigh of relief, because the solution to our ethical dilemma is surprisingly simple. Just let machines be machines. Section 5. The Power of Honest Machines, Designing for Pure Utility. This is the beautiful, efficient, and safe pivot away from deception. It's all about creating functional forms that build genuine trust without needing a fake smile to do it. The guiding design principle here is called functional morphology. Basically, it means designing robots not to mirror human shapes, but to serve their purpose with absolute precision. Form follows utility. By completely shedding the human form, we allow robots to operate dynamically. They can look like insects to crawl through narrow pipes, or plants to disperse seeds, or pure geometric shapes to navigate a warehouse. They are designed to solve problems, not pretend to be your buddy.
Now, you might be wondering, if they don't have faces, how do these honest machines talk to us? They do it through geometric clarity, using shapes that immediately show what they do. They use intentional motion, like pausing for just a split second before they turn so you can predict their path. They use simple light and sound signals, and they use predictive mechanics. This structured, nonverbal language builds massive amounts of trust because it is clear, it's unambiguous, and it is entirely honest. You never, ever have to guess what it's feeling. And this brilliantly illustrates that exact point. Blue, pause, red, double flash. Instead of a robot crying or looking visually stressed out because its internal filter is clogged, a SaaS firm simply programmed their autonomous floor scrubbers to broadcast this exact LED pulse sequence. A maintenance worker can read it instantly through a tablet camera. There is no simulated physical distress, just immediate, clear, functional communication that gets the job done faster. To maintain this kind of honesty in even more complex interactions, designers follow some very specific steps to establish clear hierarchies. Step 1. Avoid programming emotional cues entirely. Just don't do it. Step 2. Use deliberate subordinate speech. For example, having the machine say, "I suggest," rather than making definitive authoritative statements. And step 3. Make the mechanical intent visible. By doing this, we, the users, will always recognize the robot as a subordinate tool helping us make decisions, not as an emotional equal with its own feelings. Which leaves us with this final, vital question to end on. Where do you draw the line between convenience and emotional manipulation? As these machines enter our hospitals, our warehouses, and our living rooms, I challenge you to reserve your true emotional connection for living beings. The next time a machine tilts its head, or sighs, or uses a trembling voice, remember what's actually happening under the hood, and rethink exactly what it's asking of you. Thanks so much for joining me for this explainer, and I hope you walk away looking at the tech around you just a little bit differently today.